This is a short sequence on balancing combustion equations, particularly hydrocarbons. Combustion is the burning of something in oxygen gas, and that's often a hydrocarbon. That's a compound, as you see, of carbon and hydrogen. The whole point of balancing an equation is to tell how many moles of one substance will react with how many moles of another, and how many moles of product will be formed. This is a critical question of chemical engineering. We need the correct formula for each reactant and product, of course. That's the beginning, the so-called skeleton equation. And of course, we get this from our lab experiments that tells us what's reacting and what's being produced. Then, once we have the correct formulas, we can balance on paper and check our work in the lab to see if we have our coefficients correct. Now, the combustion is the burning of something in oxygen gas. For example, methane, natural gas, reacts with oxygen to form, as a complete combustion, it forms carbon dioxide and water vapor. What kind of reaction is it? Well, think about it. It must be an oxidation reduction, because oxygen gas, which has an oxidation number of 0, becomes some kind of oxygen compound, and that's going to have usually a positive oxidation number. So CH4, methane, reacts with oxygen gas to form carbon dioxide and water vapor. The oxygen has gone from an oxidation number of 0 here to the oxidation state of -2, its typical oxidation state as a compound. So here's our balanced chemical equation. We look at the equation for the combustion of methane, a 1-carbon hydrocarbon, and it has an odd number of carbon atoms, 1. Now, you need an even number of carbon atoms, of oxygen atoms here, to form carbon dioxide, because the ratio of oxygen to carbon is 2 to 1. It also has a number of hydrogens evenly divisible by 4. So 4 divided by 4 is 1. And that means you need an even number of oxygen atoms here to make water, because the ratio of oxygen to hydrogen is 1 to 2. Balancing such equations with odd numbers of carbon atoms and saturated hydrocarbons, you can't have any double bonds in a saturated hydrocarbon, is pretty easy to do. Now let's look at a 2-carbon hydrocarbon, and again it's saturated. If you look at it carefully, you see that it has an even number of carbon atoms. Therefore, you need an even number of oxygen atoms to make the carbon dioxide. But it has a number of hydrogens, 6, not evenly divisible by 4. Which means there will be an odd number of oxygen atoms to make water. In this case, you have 6 hydrogens, which would make 3 water molecules. If you balance the equation, in the end you'll see you need to multiply by 2. And as you can see, we've multiplied the balanced equation by 2. I'll show you the previous look, and then now we've got the doubled equation. So as a rule for saturated hydrocarbons, no double bonds between carbons. If there's an odd number of carbons, just balance quickly and move on. But if there's an even number of carbons, you'll end up with an oxygen coefficient like 5 halves, 7 halves, 9 halves. So pencil that number in and go ahead and balance it. And then in the end, to get rid of the 7 halves or 3 halves or whatever it is, you'll multiply the entire equation by 2 to get a correctly balanced equation with all whole number coefficients. So you can practice complete combustions where the products are carbon dioxide and water vapor. So show balanced equations for the complete combustion of C3H8, C4H10, and the unsaturated hydrocarbon benzene, C6H6. Go ahead and do that and turn off the video. And now you can practice the incomplete combustion. In incomplete combustion, the products are carbon monoxide and water vapor. So show balanced chemical equations for the incomplete combustion of these 4 compounds.